welcome back. So in last lecture we were discussing about that how the Himalaya was formed, and we also discussed the three possibilities or the three cartoons which are right now on your screen, which shows that how the continental plate was overrided the oceanic plate first. So initially the Indian plate was having the oceanic plate in front of it, and then when the subduction started taking place, there was volcanic eruption, because as we have discussed in the previous lecture, that when there is a subduction of one plate beneath the another one, there will be a melting which will result into the formation of volcanoes on the overriding plate. And then there was enclosure of Tethys Sea which existed between the Indian plate and the overriding Eurasian plate. So the Indian plate subducted below because it had an oceanic plate before it, and then the closure resulted into the collision between the oceanic plate, between the continental plate and the continental plate, because both the continental plate collided, and because of the collision what we see today is the mighty Himalayas. Now there is no more. So if you look at this three cartoons, which shows that initially the oceanic plate, which was ahead of the continental plate, or that is the Indian plate, subducted beneath the continental plate of Eurasia, resulted into the volcanic eruption on the overriding plate, and then there was this between these two plates there was a Tethys Sea which slowly started closing up, and the collision finally between the two continental plate resulted into the buckling up and folding of the sediments, resulting into the formation of the folded Himalayan belt. So since there was no more supply of the oceanic plate or any plate beneath into the asthenosphere, the volcanic activity ceased. So no more volcanic activity now we can see. What we see is the formation of the towering height of Himalayas, the mighty Himalayas, and in the frontal part of the Himalaya, that is to the south of Himalaya along the plate margin, we have a basin which was formed, and that what we see, the Indo-Gangetic plain. So basically the Indian plate was located far south of equator when it started its journey. Then initially it started its journey in this direction, and slowly it changed toward the present and collided with the Eurasian plate. So right now the motion is almost north-northeast, in the north-northeast direction. So before the breaking up of the Pangea about 2 million years ago, India was a large island situated south of equator near the Australian coast, and this was, as you remember, was the part of the Gondwana land. About 80 million years ago, India was located roughly 6,500 to 7,000 kilometers south of Asian continent, and moved at the rate of almost 9 meters per century. It is believed that the Indian plate collided with the Asian or Eurasian plate at about 40 to 50 million years ago. Its northward movement slowed down. So during this time, when there was a collision at about 40 to 50 million years ago, its speed or the movement or the velocity slowed down, and this was because of the collision, and the collision resulted into the decrease in rate of the plate motion, and is interpreted as that this was the time when the rapid uplift started of the sediments, resulting into the formation of Himalayas. So, the mighty Himalaya, which covers the distance from east to west about 2,900 kilometers, is a creation of plate tectonic forces developed by continental-continental collision. But please remember that initially there was a subduction between the continental plate and the oceanic plate, which was ahead of or in the front of the Indian plate. Now, because both the land mass, that is the continental land masses, having the same rock density, one plate could not be subducted under the another one. This phenomena of deformation resulted into the formation of Himalayas. So, the height of the highest point in Himalayas, as we know, is the Mount Everest, which is almost 8,800 meters. So, this is the configuration that the Himalaya is rising, and there are several fault plains along which the movement is taking place over the land mass, which is overriding the subducting Indian plate, or the plate which initially subducted below the Eurasian plate. So, the highest point and the deepest part is the highest point on the earth is Mount Everest, and the deepest portion on the earth is Mariana Trench. And another important features which shows the area of high seismicity are the Mediterranean Himalayan belt, which is located here. Then you have the mid-oceanic ridges or mid-Atlantic ridges, and then you have the Ring of Fire. Some facts of the Himalayan orogeny is that we have almost like 2,000 kilometer long to 2,900 kilometer long Himalayan range, and this portion, which is marked by arrow, marks the contact between the two plates or the plate boundary, active plate boundaries between the Indian plate and the Eurasian plate. So, the GPS measurements from South India, that is from Bangalore, keeping the Eurasian plate fixed, it shows that the movement is almost around 50 millimeter per year. So, India is moving towards Eurasia with a velocity of 50 millimeter per year, and out of this, up to the frontal part of the Himalayas or at the contact of these two plates, that is the Indian plate and the Eurasian plate, it consumes hardly 5 millimeter per year. So, 5 millimeter per year out of 50 millimeter is been consumed by entire Indian plate, whereas the consumption across the Himalaya, which we can say that this is the collision zone where two plates are colliding, it is maximum of 20 millimeter per year. Now, I will discuss some slides very quickly, because this gigantic landscape, which is the result of the collision of two plate, that is a landform, which also not only results into the formation of the mighty drainage basins in India or Indian subcontinent, but also this is the location which results or leads to the hazard in this region or hazard to the entire Indian plate. So, this movement or the velocity which has been shown here, that is 50 millimeter and 20 millimeter across Himalaya in a very short portion as compared to what you see the 50 millimeter deformation. This area is under high strain and responsible for triggering large magnitude earthquakes in past and in future also. So, whole plate is under deformation. So, this is at the place of the contact between the Indian plate and the Eurasian plate, and rest of the plate region is also under deformation and slowly flexing up. So, many earthquakes are seen or observed along the plate boundary and away from the plate boundary also, which have been listed here. This was 2001 earthquake and this was in 1995 or so, or 1997 Jabalpur earthquake, and so on. Now, configuration of the tectonic plates, if you look at the mosaic of earth crustal plates, we have dozens of plates which are seen or observed on the globe, and they are either colliding with respect to one another, passing by each other, resulting into the formation of lateral fault system or subduction zones, subduction plate boundary, as we have discussed between the Nazca plate and the South American plate, or we are having the collision boundary which we see between the Indian plate and the Eurasian plate. And in short, what we learn that we have three type of plate boundaries. One is divergent plate boundary, another is convergent plate boundary, and third one is transform plate boundary. And along the transform plate boundary, nothing is broken, but along the convergent plate boundary, the plate is destroyed, hence it is also termed as the destructive plate boundaries. Whereas in terms of the horizontal, in terms of the transform plate boundaries, there is an horizontal slide where two plates pass each other, and the divergent plate boundary, the new plate has been added or the new lithosphere has been created as the plate move away from one another and magma has been poured on the surface. So, the mosaic of rigid plates, if you look three type of boundaries. So, we have divergent, convergent, transform, and these are the examples for it, where we have discussed in detail about the spreading centers, about the collision zones, and about the subduction zones. So, one is the divergent plate boundary, and this are been seen which encircle the earth right from south pole to north is the mid oceanic ridge or mid Atlantic ridge, and this results into the landforms which we see as lifting or rifts, then volcanoes, and associated hazard which has been created is basically the earthquakes. Then we have divergent plate boundaries, where we have plume, where the two plates are moving away from one another, as we see in case of East African Rift Valley, and one example we discussed about the current separation and the formation of huge wide crack in the African East Valley, which is the clear cut example of the splitting up of the island. So, Rift Valley, volcanoes and associated earthquakes. Then the deepest part between the Pacific plate and the Philippine plate is marked by trench, and which is around 11,035 meter deep, termed as Mariana's Trench. So, these are the features which are commonly seen when the oceanic plate subduct below the oceanic plate. So, we have the deep trenches, even and the earthquakes which will be triggered here will be deep as well as shallow, and then we will have volcanic arc on the overriding plate and the trenches between the contact between the two, that is the contact between the two plates. So, the deepest trench on earth. Then again another convergent plate boundary is where the oceanic plate subduct below the continental plate. The example is the volcanic eruption on the South American plate side and the formation of the Andes mountain. So, volcanic mountain chain, folded mountains and deep earthquakes as well as shallow earthquakes will be experienced in this region. Then comes the continent and continental convergence. The best example of this convergence is Himalayas, and as we discussed way back in the beginning, that this will result into the crustal thickening, folded mountains and the shallow earthquakes. So, this is an example between the Indian plate and the Eurasian plate, where the Eurasian plate is overriding the Indian plate, because initially the Indian plate, which had an oceanic plate in front, subducted below the Eurasian plate. Then comes the transform plate boundaries, for example, which exist along the mid-Atlantic ridge or mid-oceanic ridge, and this lateral faults or transform faults also triggers earthquakes along it. So, these are the spreading center which have been shown here. Now, the movement, if you take this as a piercing point, it is opposite what has been seen here, but the movement which is shown here is based on the movement of this portion of the plate, because from the center here where I am putting my cursor, this portion of the plate is moving in this direction, and with this the movement is in this direction. Hence, along this fault or the transform plate boundary, the movement is in this direction and this side is in this direction. So, on your right the movement is towards you, and on your left the movement is away from you, and this type of movement is termed as right lateral movement. But if you take this piercing point, this spreading center, the movement is opposite, because this portion is located here and this portion is located here. So, the direction is in opposite to what you see here. So, do not confuse between the direction which has been shown here, but the actual feedback which we should take from this is the correct direction of motion along this transform fault. Again, transform fault plate boundaries, one of the best example is between the Pacific plate and North American plate, where the two plates are moving along and or showing the horizontal movement, and of course with an oblique slip it also has resulted into the formation of mountains along the plate margin, and this movement is what we see is right lateral. So, again lateral transform faults and will be definitely associated with earthquakes. Now, very important portion which we can talk here is the earth as geodynamo. Now, which layer, the interior of earth is responsible for the magnetism or providing the magnetism or act as a geodynamo which keep generating the convection current and which helps the earth to rotate. So, this is very important. So, earth as geodynamo, let us look at the few slides and try to understand that the interior of earth, that is the outer core which is liquid, is responsible for the magnetic field of the earth, and this is very important. And why it is so that the liquid, the outer core is liquid and the inner core is solid. So, this we will discuss in few slides. So, if you see here the north magnetic pole and the geographic north pole, they are about 11 degree apart, and the north pole is inclined towards, or north magnetic pole is inclined towards east with respect to the geographic north. Geographic north is almost what we say north south, but the north magnetic pole is 11 degree inclined towards east. So, the earth act as a large bar, magnet bar. So, the earth magnetic field is much like the field that would be produced if a giant magnet were placed at the earth's center and slightly inclined, that is 11 degree from the axis of rotation. So, the earth magnetic field will act as a huge or giant magnetic bar if it has been kept 11 degree inclined from the geographic north. So, the line of magnetic forces produced by such a bar magnet are shown as it has been shown here, that it moves from here and get into this. Okay. So, this is the magnetic forces, and a compass needle points to the north magnetic pole because it orients in the direction of local line of forces. So, the force which is acting in this direction along the 11 degree inclined magnetic bar, the needle of the compass will also align along the magnetic pole or the magnetic. So, the compass needle points to north magnetic pole because it orients in direction of local lines of forces. So, this is what we are discussing. Now, further, Earth's center resembles a typical permanent dipolar magnet bar or magnetic bar. However, this hypothesis can be easily rejected. Now, the formation of magnet, it is not possible because a permanent magnet will be destroyed beyond 500 degree centigrade. So, 500 degree centigrade temperature will result into the destruction of the permanent magnet. Then what is happening? We know that the temperature in Earth's deep interior are much higher, thousands of degrees at its center. So, unless the magnetic or the magnetism it continuously or constantly regenerated, it cannot be maintained. So, it cannot be maintained without regeneration, because 500 degree the permanent magnet will be destroyed. Then why we are still having the magnetic field that exists? So this is very important, that unless there is a regeneration of the magnet or magnetic field, the permanent magnet which we observe or experience, the magnetic forces will not exist. So further it was been discussed, and the scientists suggested a theory that heat flowing out of earth core, now we are talking about the earth core, so the heat flowing out of the earth core causes convection that generates and maintain the magnetic field. Now this is very important, but the question again is, the magnetic field is created by convection in the outer core, but not by convection in the mantle. It has been suggested that the outer core is primarily made up of iron. Now if you remember the composition of the earth, so the interior, what we have first on the top, we have the crust, which is comprised of silica, magnesia and aluminum magnesium rocks, Sial and Sima. So we have continental crust, we have oceanic crust, then we come down to the asthenosphere, which is partially molten, and then mesosphere and so on. So the mantle is again not composed of fully iron, but as you move deeper into the interior of core, mostly the interior of core, that is the interior of earth, and the inner core and the outer core is comprised of nickel and iron, whereas the inner core is maximum, you will see the iron, because the heavier material sink down. Now this is one of the reason that we are talking about, that the heat which has been generated or available in the interior of earth, because the heat increases and pressure increases as you move from the earth's surface towards the interior of earth, and it goes more than 6000 degrees centigrade. So the heat which is more in the region of the outer core is responsible for the development of the convection currents, very much similar to what you see in the asthenosphere. But in asthenosphere, the convection current is slow as compared to what we see or experience in the outer core. So the outer core preliminary, it is comprised or made up of iron, which is very good electrical conductor, whereas the silicate rock of the mantle, because the mantle you have silicate rocks, as we were talking about the if you take into consideration the composition of the earth's interior, and this silicate rocks in mantle are poor electrical conductors. So the convection or convective motion are 1,000,000 times more rapid in the liquid outer core than in solid mantle. This rapid motion stirs up electric currents in the iron to create a geodynamo with a strong magnetic field, and this is one of the reasons why we see the generation of magnetic field in this region. So, this was the part of the geodynamo. So, why the outer core can be a liquid while the deep mantle is a solid? The reason is that the geologists were puzzled by the existence of the solid inner core when the temperature inside the earth increases with depth. So, inner core is solid whereas the outer core is liquid. So, it has been estimated that the temperature rises from 3500 degrees centigrade at the core mantle boundary to almost 5000 degrees centigrade in the center and more. So, it goes more than 5000 degrees centigrade up to the inner core. Therefore, if the inner core is hotter, how could it be the inner core be solid while the outer core is molten? This is a question. So, the reason is the mystery was eventually solved by a laboratory experiment on iron nickel alloy, which shows that the solid nature was due to higher pressure rather than the temperature of the earth center. So, this was the reason why you have the inner core as solid because of the higher pressure and not because of the temperature, whereas the outer core is liquid. And further, as we have discussed, that the magnetic polarity never remains the same, as what we see now is north south, but at some point of time the polarity will be reversed, and this was observed in the area of spreading centers where we have negative positive anomalies, which has been shown by in the next slide, which will be showing. So, the term paleomagnetism, so paleomagnetism mainly is the study where the magnetic field have been studied, and the rocks which are having the different magnetic signatures are been reported. So, the term paleomagnetism refer to the study of magnetism of rocks at the time their magnetic signatures are formed. The causes of magnetic reversal, it's not fully known, but it is related to the change in the convection moment of the liquid material in the outer core and the process occurring in the inner core. So, in short, this is another important point, that if there is disturbance in the convection moments, then the polarity may change. So, the convection moment in the outer core can result into the magnetic reversal. So, the reversal in the earth magnetic field are apparently random. This again, it is not known why, but on average every few thousand years it changes. The change in the polarity of Earth's magnetic field takes a few thousand years to occur, which a geological term is very short time. So, this has been shown here in the mid-oceanic ridges, where you have the different polarity, where the black one is the normal polarity, that is the north south what we see now, and the negative one where the north pole becomes the south and south pole is taken up by the north. So, I will stop here and we will continue in the next lecture. Thank you so much.